Okay, so let's look at the first problem. As limit approaches -3 from the right side is -4, and as limit approaches 5 from the right side is -2, so that'd be 3 times 2, or -2, so that's -6. So this would be 4 plus -6, so -4 minus 6, and this will get you -10. For the second one, it would be 1/2 of limit approaches 1. Limit approaches 1 is -2, so that's 1/2 of -2, which is just -1, plus cosine of pi. Cosine of pi is -1, so this would be -1 plus -1, which gets you -2. For number 3, if you look at limit approaches 4 from the left side, so that would be just going to infinity. And as for number 4, limit approaches -infinity, f of x will be going to -infinity as well. For number 5, limit approaches -3. If you look at it, there's a jump discontinuity there, so this will be do not exist or undefined. So for these problems, from number 6 to 11, so let's do number 6. So you factor out the x, that becomes x squared minus 2x plus 3 over x, and you could just cancel out the x. And here you could just plug in 0 for every x. So 0 squared is 0, minus 2 times 0, which is 0, and plus 3. So this will be 0 minus 0 plus 3, which is just 3. And you can write it as limit x approaches 0, f of x equals 3. For number 7, you will need to kind of separate it out and factor tangent. So this will become 3 over x times sine x over x, and also cosine of x over cosine of x. So these just cancels out, and this becomes 3 multiplied by 1, because sine of x over x is 1. So you just get 3. And so limit as x approaches 0, f of x equals 3. For number 8, we could factor out the numerator as x minus 2 and x plus 2. And the denominator, x minus 3 and x plus 2. We could cancel out the x plus 2's. And now we just plug in a value that's greater than 3. So we could use 3.1. So 3.1 minus 2 over 3.1 minus 3. This will be 1.1 over 0.1. And since it's positive, it will be limit as x approaches 3 positive equals infinity. Oh wait, forgot the f of x. For number 9, we don't know what ln is, but we could do this. So as limit of x approaches 2 from the left side, ln of, so if it's 2, we just plug in something that's smaller than 2, so 1.9 would work, and then we add 2, that gives you 0.1, and limit of x approaches 2 from the left side would be ln of 0.1, which is infinity, since it's a positive value. For number 10, we don't really have to do anything here. It's just a shortcut. So you take the largest degree and you divide it by the largest degree. So this will be just negative 1/3. For number 11, you get limit as x approaches infinity, f of x plus 0, or f of x 5 plus 0. Because 5 over infinity, you get a very small value, which is equal to 0. So the answer is 5. So limit as x approaches infinity, f of x equals 5. Okay, so for question 12, it says, is g of x is continuous at -2? So we want to use this equation and this. So we just plug in -2. So as limit of x approaches -2, g of x equal to 3 absolute value of x plus 3. And that equals 3, because if we plug in x for -2, we plug in -2 for x, we get 1. Absolute value of 1 is just 1. 3 times 1 is 3. And this is not equal to limit of x approaches -2, g of x cosine of pi of x over 2. Because that just equals -1. It's cosine of negative pi, which is just -1. So therefore, g of x is not continuous at x equals -2. For 13, it asks for what values of a is g of x continuous at 2. So going back to our equation, we will use the second one and the third one, because the second one, x is smaller than 2, and for the third one, x is greater than 2. So for here, we just get limit x approaches to g of x is a2 squared plus 4 is equal to -1. And limit of x approaches to g of x a4 plus 4 equal to -1. So if we move the 4 to the right side, that'd be limit x approaches to g of x a4 equals -5. And so x approaches to g of x, a has to equal -5/4. So that is the answer. So for 14, it asks for what values of b is f of x discontinuous. Then we have to come back to the graph here. If we look at the graph, so the first one would be at 0, a discontinuous at 0, and that's infinite. And the other one would be at 4, and that's a removable. So from what we know, we have to prove these points. So limit x approaches 0, f of x equals infinity. So a infinite discontinuity at zero. Okay. The next one is at 4, so limit x approaches 4, f of x equals so limit of x approaches 4 equals 1, but it is not the same as f of 4 since that is equal to 3. So therefore there is a removable discontinuity. So for 15, you just basically plug it in. So limit x approaches 2 from the right hand side, you get bracket -5/4 plus 2, 1, which is equal to limit -5/4 plus 2. Limit, so you need to now find the common denominator, and which will be x to 2, and then you get 8/4 minus 5/4, and it will give you the answer limit x approaches 2 equals 3/4.